This is the second video supplement for CIS 343, Grand Valley State University's Programming Languages course. This video demonstrates the basics of Kava scheme expressions and defining functions. For this video, I'm going to assume that, first, you have Kava set up and ready to use somewhere, for example, on EOS or on your own machine. Remember, this was covered in the previous video. Also, I'm going to assume that you've read the relevant sections in our textbook. All right, so now let's look at some scheme code. Now, the main feature of scheme, and well, any language derived from Lisp for that matter, is that every statement is a list. And most of those lists are interpreted as function calls. So here, let me launch the Kava interpreter, and then I'm going to enter +5, 4, which will add 5 and 4 and give 9. And to have a second example on the screen, I'm going to do, how about 4, 5, 6, 7, which when added is 22. Now notice what I have here are two lists. Both of these lists are delineated by parentheses. The first element in the list is the function to be called, in this case the addition function, and the remaining elements in the list are the parameters. For addition, that's the numbers to be added. And so writing scheme code is just a matter of nesting function calls. Now obviously it's not quite that easy, but that is what it boils down to. So for example, try writing a statement that computes the expression 5 times the quantity 6 plus 7. Now you'll see I put a semicolon there at the beginning because semicolons are what delineate comments, so I can put that up here quickly on the screen without causing any errors. All right, so try to rewrite that expression in scheme. In this case, the key idea is to recognize which operation needs to be performed first, which for this expression is addition, and the operations performed first need to be nested most deeply. Right? We need to add 6 and 7 together because that result of 13 is a parameter to the multiplication function. So this expression would look like this. We're going to multiply 5 and the result of adding 6 and 7. Notice how that addition call is nested inside of the multiplication call, and it should give us our result of 13 times 5, which is in fact 65. All right, now we're going to use this as more than a calculator, of course, so we need to move up a level and we need to have some functions so we can reuse this code we're adding. As an example, let's write a function that converts Celsius to Fahrenheit. Now, the statement for defining a function has the same form as all other scheme expressions. It looks like a list. So here I'll start with simply an empty set of parens. Right now I've got the list with nothing in it. And in this list, the first element is going to be the keyword define. And then the second element is itself a list. The first element of this nested list will be the name of the function, which I'll call it C to F. And then the remaining elements of this nested list are the parameters to the function. In this case, there's only one. Now, all the other elements of this define list, this top level list, are just the scheme statements that implement the function. The return value of the function will be the value of the final statement. Now, in this case, we're only going to have one statement. So pause and finish this out by implementing the conversion from Celsius to Fahrenheit. I'll put the formula up here on the screen for you in case you've forgotten. All right, so just like the first time, we have to figure out what our inside operation is, what's going to be done first, and in that case, it's the division. So the desired result of this function is the result of adding the product of our parameter and 9/5 to 32. And now I'm going to delete this last paren and put it back to make sure I've got everything lined up right. So that last paren closes out the addition function, so I need one more to close the define. So you may have heard that Lisp stands for lots of stupid parentheses, and you can see where that reputation has come from here. But this code should work. Notice there's nothing put on the screen here because all I've done is defined a function. But at this point, I can now call the function. So I have a list. The first parameter is the name of the function I want to call. The second element of the list is the parameter. So 100 degrees Celsius is 212 degrees Fahrenheit. All right, that looks promising. And 0 degrees Celsius is 32 degrees Fahrenheit. All right, so far so good. What else could we put in? How about 40 degrees Celsius is 104 degrees Fahrenheit, and I happen to know that because parts of Britain have recently been hitting 40 degrees Celsius, and that's been big news at the time. Hopefully that's no longer big news by the time you're watching the video. So now you have the knowledge to write and call simple arithmetic-based functions in Scheme. In the next video, I'll show you how to write some slightly more complicated code by showing you how to use name bindings, which are roughly equivalent to variables in functional programming.